So here we have a problem that says the popularity of politicians X and Y in millions of voters t years after the election is given by the function x of t is equal to 5 plus 8 over square root of t, and y of t is equal to 10 minus 1 over t to the power of 3 halves, respectively, for when t is between 1 and 4. So we have part A and part B of the problem, but in this video I'm just going to do part B. Part B asks us to show that x and y are equally popular at some time between 1 and 4 years after the election. So what we're trying to do here is we're trying to show that these two functions are equal at some time, but we don't necessarily have to find what that precise time is. So if we were to just start by setting the two functions equal, 5 plus 8 over square root of t is equal to 10 minus 1 over t to the power of 3 halves. When we set these two equal, if we can solve for t, that would give us the precise time at which they are equally popular. But this is not simple to solve algebraically, and we don't actually need to know at what time that they're equally popular. We just need to show that they're equally popular at some time between 1 and 4 years after the election. So I'm going to use a different type of a strategy using the idea of the intermediate value theorem. I'm going to find my x of 1. So x of 1 is equal to 5 plus 8 over square root of 1. The square root of 1 is just 1, so that would be 5 plus 8, which is equal to 13. And similarly, I'm going to find x of 4. That x of 4 is 5 plus 8 over the square root of 4. The square root of 4 is 2, so that would be 5 plus 8 divided by 2 is 4, which 5 plus 4 is 9. Now let's find y of 1. Y of 1 is 10 minus 1 over 1 to the power of 3 halves. 1 to the power of anything is just 1, so that would be 10 minus 1 over 1 is 1. So 10 minus 1 is 9. And y of 4 is 10 minus 1 over 4 to the power of 3 halves. 4 to the power of 3 halves is the same thing as the square root of 4 cubed. So that would be 10 minus 1 over the square root of 4 to the power of 3. And that I found by using that if you have a nth root of x to the power of m, that's equal to x to the power of m over n. So that's how you can, oops, that should be an n. Converting between the fractional exponent form and the radical form, you can go back and forth with those. So then 4 to the power of 3 is 64, so this would be 10 minus 1 over the square root of 64, which is, the square root of 64 is 8, so that would be 10 minus 1 over 8, which would simplify. We can find a common denominator of 8 to make 80 over 8 minus 1 over 8 would be 79 over 8. And that approximately, as a decimal, 79 divided by 8 is 9.875. Or it's exactly equal to 9.875. Okay. So let's think about what this means. If we draw a little sketch of our two functions, I'll draw my my x function in blue, or 2 points that we know in our x function. So if this is 1 and this is 4, then when x is 1, when t is 1, x is 13. Let's put 13 there and 9 maybe like here. So when t is 1, x is 13. When t is 4, x is 9. So we have these 2 points that we know. We don't really know what's going to happen in between them, except if we know that the function is continuous between 1 and 4, then that means that the function at some point between 1 and 4 is going to have to pass through all the numbers between 13 and 9. It might go up some and then back down, or it might do all sorts of things other than just go straight through. But it is going to have to pass through all of the numbers between 13 and 9. And then similarly for y, I'll do that one in, let's see, maybe like orange, for example. So for y, when t is 1, y is 9. And when t is 4, y is almost 10. So 9.875 would be something like here. So also, because we know that y is continuous when t is between 1 and 4, that means it's going to have to span all the numbers between 9 and 9.875. So it's going to have to cross through all of these numbers at least once. It might do other crazy things, but it's going to need to pass through all of those numbers. So since the x spans all of the numbers between 9 and 13, and y spans all the numbers between 9 and 9.875, they're going to have to cross through at some point in between for assuming that the two functions are both continuous. And we do know that they are both continuous for numbers between 1 and 4. They would be discontinuous. So there's 3 primary ways that you can have functions be discontinuous. One is division by 0. And both of these functions would have division by 0, but only at a value of t equals 0. And we're not looking when t equals 0. We're only looking for t is between 1 and 4. Also, you can also have discontinuities when you have negatives under even radicals. And both of these functions also have that. However, you would only have a negative under an even radical when t would be a negative for both of these functions. So that would only happen in the region where t is negative, not between 1 and 4 for t. And the third primary way is if you have a logarithm, which we don't have a logarithm in these problems. So we wouldn't have any other discontinuities other than just at 0 and at numbers less than 0, or for negative numbers. Okay, so to show that X and Y are equally popular at some time between 1 and 4 years after the election, let's say that since X of t and Y of t are continuous when t is 1 to 4, by the intermediate value theorem, we can say that X of t must be at least all values between 9 and 13, and y of t must be all values between 9 and 79/8. So since these values span each other, since these values span each other, the two functions must cross at some point between t is 1 to 4. So the two politicians are equally popular at some value of t between 1 and 4. Okay. So I hope this step-by-step solution was helpful for you. If you have any questions, feel free to leave those down in the comments, or I also have my email listed down in the description below, that if you have a problem that you would like to see a video on and it's difficult to put in the comments, you can feel free to email me that and I will do my best to get to it. Well, happy studies and thanks for watching.